It should be another draft physics video presentation. I believe so. So again, another conversation about the, opposing the under-evidenced arrogance of physicists. Some of what are considered to be the most intelligent people, these physicists, and yet they're guilty of such a mundane, crude, silly crime of arrogance. I mean, that's one you can figure out when you're a kid, kind of thing. That it's folly, to presume yourself to have skills you don't have, to fake it. And they have faked their foundations entirely. They know them to be weak and their stories now to be incredible, and they just don't care to hear it. Because they're so freaking arrogant. Well, we couldn't have made a mistake. We couldn't be completely talking crap. So they just keep talking as if they've proven something they haven't come close to the burden. And that's the simple argument. The evidence for what they're saying is the truth is incredibly weak. And it hasn't gotten stronger over time. They've just come up with more elaborate and incomprehensibly complex experiments to say we've done it, when they haven't done any of what they need to do, which is prove some of their claims. Again, there are speculations about their ability to use an interferometer and see distances that are thousands of times smaller than a proton. Just incredibly bold statements, considering their inability to provide any evidence that they can do any such thing besides proving they saw something at that range that is doubtably seen. It's they say so. There's no other evidence. Very circular. We've proven it with our proof of the proof that was the proof of the proof. No. Anyway, so this whole thing about this is the strong force argument, that they invented a force because they knew there was a phenomenon. The same phenomenon happens to electrons. So, let's just understand what, is kind of bizarre, right? So they understand that electrons repel each other and then protons repel each other. And what they understand that is, if they could smash electrons really close to each other, they'd have to come up with some explanation, because it's an incredibly strong force. It gets stronger and stronger as they get closer and closer. And obviously, as I've pointed out, the existence of a ping pong ball or some kind of energy trapped between them provides a perfect explanation for why this phenomenon happens. And the fact that you could have them theoretically so close that the ping pong ball barely even bounces. It's bouncing so fast, and so it's having interactions at some sort of Planck number of interactions per second, some insane, you can go up to, it's essentially infinite, right? You can create an infinitely small distance, because you can keep getting a little tiny bit closer and a little tiny bit closer theoretically, right? So you run into the Planck laws of distance. And before you get to that, though, it's gonna be some gigantic number, 57 times 10 to the 57th kind of gigantic number for how much pressure this would be if I could get electrons. If I could get electrons that close, this little Planck line of distance. And the same is true for protons. So they know that in the nucleus of the atom, the nucleus is a small thing, that these protons are really close to each other. So they know there's this incredible amount of energy trapped between them. Theoretically, that is, if you don't account for there being anything in between them, if you don't account for the fact that there's some other reason why the two things are close to each other. And I would speculate that the obvious reason is because there's an electron between them, and that negates the whole game, because the electron dispenses with the little bouncing ball. It doesn't bounce back and forth between the electron and the proton, and the electron and the proton. There are no infinite interactions. There are no huge number of interactions taking place anymore. And so what was something that was impossible because it was such a tremendous amount of energy is made incredibly possible by just adding something they know is in the atom. They already know that these things are in the nucleus. They already know there's something called a neutron, and they're there for some kind of reason. They're not there doing nothing. Do nothing, that's not what N doesn't mean do nothing. That's not what it means. Okay, it's an actual player. So they just forget that this is an actual player and that it could have a constituent bit that's doing this. And they just pretend that this and this are doing something that seems impossible. So now there must be this force, this strong nuclear force, this new force that's somehow pushing these things two together by some magical force. Some new magical force must be making this happen. When, no, you don't need a magical force. You just need an electron. So anyway, we'll get to more. So we'll play this video and just the arrogance of it. Like again, they just say all this stuff is true. They haven't proven any of it to be true.
When we place two protons next to each other in close proximity, we know for sure that they will repel due to their positive charge.
Right, so we know that for sure. That sort of is for sure. That the two positive charges always function this way, the negative charges always function this way. Magnets are pretty reliable. If I turn them north-south, and if I north-south, and I have them in the same configuration, north against north and south against south, they'll always do this. They never fail to do it. So yeah, it's a pretty reliable experiment.
We call this force of repulsion or attraction the electromagnetic force. But let's...
Right, well, it really should just be called what it is, a charge. That's all it is.
Let's think about the nucleus of an atom. Shouldn't the protons repel each other?
Right, so they just drew a nucleus of an atom and just kept all the neutrons out. No neutrons allowed in, So first failure right there, right, is to say, let's pretend neutrons don't do anything.
So why doesn't the nucleus break apart? This tells us...
So there's obviously a reason, and you just don't seem to really want to think about all the possible answers to the question because you have a standard silly model of mush, and you think there's some new, different force. See, I mean, they have a model where they have all these forces are moving exactly the same speed, and yet they play this game like they're all different things. They're all different kinds of fields. They think there's an electron field. They think there's a proton field. They think there's an anti-proton field, an anti-electron field. They think everything has its own special field that manipulates it. I mean, they have no evidence of any of these fields existing. Why would you think the universe does that? The universe, on an elemental level, creates a field for every single particle. I mean, it doesn't sound like the right answer to me. Einstein didn't think so.
That there must be another mysterious force that overcomes the repulsive electromagnetic force.
So these cartoons are just so special. So some strong force, some new magical instrument must make it happen. New gremlins. We have to make a new gremlin to explain it. A new boogeyman, a new pixie, a new fairy.
Here is where the strong nuclear force comes in. Just like the electromagnetic force, the strong nuclear force is another one.
So they keep putting these things together like they've actually put any of these puzzle pieces together. They've put none of them together. The only thing they've figured out is the same thing, to some extent, is magnetism and electricity, but obviously they still call them magnetism electricity, and they think there's no such thing as a magnetic monopole and lots of silly things.
One of the four fundamental forces.
Right, so they haven't connected any of those dots. The weak force is, again, just an inability to recognize that everything is in environments. Environments are more complex than what you think they are. So again, the nucleus is more than just protons. You already know that.
And it acts to hold the nucleus together. The range of the strong force is extremely small compared to the other forces.
Well, that's only because they've invented it, right? They invented it a nothing, and now they have to explain why there's no evidence of their new magical force. So they're saying, yes, the force is just contained in the nucleus because we can't measure this super force anywhere else. So they say it has small range because they're conceding there's no evidence for it. It obviously doesn't have any range because we can't see it anywhere. We can't find it, we can't detect it, it doesn't show itself in any way. And the simple answer is the neutrons are what's creating the circumstance where you're negating half the charge potential of the nucleus, and what you really have is the leftover proton. So if you understand the neutron is really a proton and an electron, which they already know, you have the answer to the question. You don't need any special new force.
The order of magnitude of this range is comparable to the diameter of a medium-sized nucleus. So if the proton...
So just conveniently, it's the average. The average is the average of the average nucleus because we can't detect any indication of any extra force pushing in on the atom to keep the protons together. It's just a magical force that forces protons together. It's, on its face, not an answer. Oh, come on, computer.
is taken far enough away from the other protons in the nucleus, it will stop experiencing the strong nuclear force.
Yeah, it just magically goes away. See, so every circumstance except inside the nucleus is the only place it can exist, and somehow the whole thing, the whole theory, doesn't exist anymore as soon as I put protons and electrons at their normal distance from each other. Then they just turn back into protons and electrons. Because that's because you didn't put any neutrons in the way, did you? Yeah, so again, just forget about what you know to be a truth. Neutrons exist and they're there for a reason. They just think they're there because it's fun to be in a nucleus. They won a free ticket, like a contest. Be inside a nucleus, And so they got on the boat and they didn't have to pay, and they're just sitting there in the nucleus boat going, hey, I'm on a nucleus. I'm sorry, it's mockably silly.
We can look at the size of the strong nuclear force on a distance graph. This distance here is how far apart the protons are from each other. And the distance between them is approximately 10 to the power of minus 15 meters.
Right, so they just make this stuff up too, frankly, because they really don't know how big a proton is, so this is all kind of just made up stuff. They have a vague notion of how big an atom nucleus is because of the hardness of hitting it. But the only thing you can really hit it with is something that's charged. So you're always going to get an exaggerated number. You're not going to get the actual size of something. When you're hitting charges with charges, it gets pretty complicated. So if you had a thing and you wanted to know how big it is, right? It'd be really nice if you could send little tiny things at it, and then you could get its exact shape, because you could send a little tiny thing and, no big deal. And bounce it back like light. So that's what light does for us. It's a little tiny thing hitting big giant things, so I can see each little piece of it and I can get a pretty good estimate of its size. Well, obviously they're not allowed to do that. They have protons and electrons to work with, and that's what's inside the nucleus. And so obviously when they're hitting it with something charged in the first place, so it's not even as simple as the light argument, because we know we're hitting charged particles. And so what they end up with is, the only thing we can really throw at it is electrons, and to do this kind of an experiment. And so we know we're going to get some of this effect. The stuff is going to fly off at angles. It's going to deflect because electrons repel electrons and that kind of thing. And the opposite can happen. The attraction can cause all kind of distortion. So we're not going to get a clear shadow of the proton. So we're not going to get a real good understanding of its exact size, because we're not measuring it with a ruler that has small enough numbers on it,
The protons no longer exert or experience the strong nuclear force. But when we put them closer together, they begin to feel an attractive force.
So they say this stuff, and you're just saying that they feel an attractive force. They feel it. They don't explain how this environment could possibly create it. So again, just do this one more time. So again, the argument is pretty simple. There's a simple explanation. Okay, and the simple explanation is they know a neutron is a electron and a proton. All right, and they know there's usually one neutron per proton in the nucleus. So you have a proton, and then you have another proton from the neutron, and then you have the magical electron. And if you put it right in between, the argument would be that all the force that reflects off of electrons leaks out of the protons, and all the force that is reflective, that would bounce back and forth between the protons, leaks out of the electron, creating very low pressure between the two and allowing something that hates this plus passionately, but with this in between, it's okay. I did this just yesterday, I think. Look, you could think of it this way. If I take a magnet, I put the north side between two south sides, right? So these magnets are going this way. Well, draw it correctly, Gary. All right. So I put two, you'd understand that even though these two things are supposed to be highly repulsive, these two things don't want to go anywhere near each other. If I put this in between them, they're going to stick right to the surface. They're going to get as close as they can. And now these two things will be closer than they should be. So if I put a thinner magnet in here, right, I can obviously get these two things much closer than it would be possible in free space to do it. The two south ends would repel each other. They couldn't get any closer than this without applying a substantial force. But if I just stick the other magnet in the opposite direction, it works out just fine. So we know this function exists. And this is all just saying proton, okay? Proton, electron, proton. So all that is neutron here, proton here. Now I have two protons right next to each other. Very close to each other.
At some distance, when they're very close together, they have the maximum attractive strong nuclear force. But if we continue to bring them closer together, they will soon be pulled into a singularity to prevent...
Okay, so then now we have this idea that now they're going to assume they can smash two protons into the same space. Well, they have no evidence of that. Certainly no evidence you can ever do that with an electron. Let's put them in the same spot. No, it doesn't happen. Just silly talk. A singularity. What is this?
This from happening, a strong nuclear force now switches to become a repulsive force.
So again, makes no sense at all. So this strong force pushing them together now becomes a strong force pushing them apart. I mean, it's just baby talk. No, pushing them together. Yeah, so just nothing. Just terrible. Terrible, awful physics. Again, they're describing it as a cartoon because it's cartoon physics. You really can't do it in any kind of disciplined or straight up manner because it really doesn't make any sense to create this new force when these are just charged elements. They're just protons and electrons. And again, the neutron decays into a proton and an electron. So why the baby talk? Why this conversation as if you don't understand that the neutron is not really neutral, that it's a composite of a positive and a negative. It's a dipole. It's a magnet. And a magnet allows you to get things closer together. All right. Well, like I said, you can only be reasonable. I think I'll cut these into two different videos. There's another subject that I saw an old Sabine Hassenpfeffer-Felder video on light, so I think I'll do that one because it's pretty bad. But anyway, like I said, I can only offer you some reasoning. You're just impervious to it. You're impervious to it. Okay, you don't want to be reasonable. You don't want to be a fair cop. You don't want to really be in any way scientific and disciplined and rational. I'm just saying they really don't have anything to base this on. Then they made too quick a jump to a conclusion. They just didn't want to wait for answers. So they just grasped at anything that was available. And it's very much the same story of the human race with religion. They just didn't have answers for anything, so they went to the quick and easy one. They invented an invisible man that's doing all kinds of invisible things. So again, they just create another force, create another force. We'll call this one the Holy Ghost, this one's Jehovah, this one's Mohammed, this one's David, this one's... They're just creating a bunch of fake characters to, or give them fake powers, to explain reality. And it's pathetically unscientific. But go ahead, just quit being it. You just keep being arrogant assholes. What can I do? Like I said, you can't reason with you morons. And you'll sit there and insult other people and mock flat earthers and mock this and mock that. You're just as much a science denier as they are. You're denying the evidence. You're just denying the fact. You won't admit the evidence is weak. You won't admit that the conclusions aren't consistent. That is, you can't match your bent space crap with your quantum mechanic crap, with your standard model crap. These things don't fit together in any rational way. You just won't admit that this is an undone story, that this isn't the right answer, that this is not even close, maybe, to what a right answer should look like. So go ahead. Just keep riding your fantasy bullshit story. Just keep being a frickin' apostle for your Christ. To just keep being a deluded, silly Jehovah Witness. Jeez. Keep preaching your crap and being arrogant and obnoxious. Be thumping your stupid, ignorant Bibles. Your bad theory Bibles.